Hello, physics students. Good morning, or good afternoon, or good night. This is Mr. Thrasher's last online video. We are wrapping up. We are going to be done with our unit after this video. So we are going to remember some things about absorption and fingerprints of light. We're going to learn what stars like the sun are made of. And then Mr. Thrasher is going to help you with your last activity for the semester. Okay, so this is an important video. We're wrapping everything up, and this will help with your final activity. Okay, let's get into our do now. Our physics objective. It says, I can identify atoms by the light they absorb and scatter. We saw this physics objective before. We learned that atoms have fingerprints. Fingerprints from light. We're going to remember that, and then you're going to do an activity where you identify light by absorption graphs to determine what atoms are in stars. You're going to be a scientist, an astronomer. It's the same science that astronomers do today. Okay, now our what do you think? We have another can you remember? Our what do you think says, what is the name of one atom? Ooh, a little difficult. Can you remember the name of an atom? What's the name of one atom or molecule? Try and take a guess. I just want to guess. You don't have to Google an answer. If you're wrong, that's okay. But you could write down, I think the name of one atom is, we've talked about some by name. It's not important that you know the names, but just do you remember the name of one atom? Okay, go ahead, write your sentence. All right, let's remember our original question because this is it. We're going to be done with this unit. But I showed you this slide. It said, what are stars made of? Stars like this. And we learned about our sun. We had to learn about light. And we are now finishing up by learning about atoms and the fingerprint of light that atoms have. So we're going to answer this. What are stars made of right now? Get ready. Here we go. From the last video, we remembered or we learned that fingerprints exist for atoms. Just like I have a specific fingerprint, certain atoms absorb certain types of light. This atom, for example, maybe this is the atom hydrogen. Did you write that down for your what do you think? That's the name of one type of atom, hydrogen. Just like I have a fingerprint, hydrogen always absorbs these colors. Okay, now hydrogen maybe absorbs several. Look, there's multiple. It's complicated, not just one. There are several. Look, there's kind of red, and it looks like kind of yellow, a couple green, but only hydrogen has this pattern, has this fingerprint. So scientists can look at something like this, or scientists can look at a sun, a star. And here's the graph. Remember, this is the graph of that light. This is what our sun looks like. A lot of light, a little light. And all stars have this shape. But just like this is black, zero light, absorption. When you see this, oh, look at this, very little light, absorption. This corresponds, it's the same thing, absorption, right here, absorption. Maybe, for example, oh, see this, absorption. When you see these dips. These dips. Here's another, a dip. Oh, that's light being absorbed. And we can identify the size, the type of that light. So these are absorption lines. That's what scientists call them. Remember, here's that same shape. All stars have this shape, but they will have different absorptions based on the atoms. Because remember, atoms absorb certain kinds of light. They're fingerprints. Okay? Again, this is the same thing. Absorption, 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 absorption. It's the same thing. This is a fingerprint. These are fingerprints. And this is how scientists who look out in outer space are called astronomers. This is how they study what stars are made of. Now, let's think about here on Earth. Scientists have found around 100 different types of atoms. Remember, we learned that atoms create everything around us. Everything is created from atoms. And there's around 100 different types. Types with names like hydrogen, helium, calcium, carbon, potassium. Did you remember some of those? They make molecules like water. Have you heard of water? Carbon monoxide. It gets more and more complicated. But there's around 100 different types of atoms. So scientists can take those atoms and look at the fingerprints. Just like a police officer can find your fingerprint, scientists can look at the fingerprints of atoms, the light that those atoms absorb. Oh, so we have the fingerprints of 100 different types of atoms. So this is a table showing different types of atoms. Okay, this is hydrogen and lithium and beryllium, and we have a potassium here and calcium here. We have over here gold, and we have tin. There's many different types of atoms. But for all of these, this is around 100. I like this next slide. Ooh, notice it's the same kind of picture. It's the same picture. Look, very similar. But this is showing the fingerprints. This is the fingerprint of hydrogen. This is the fingerprint of beryllium. Okay, this is the fingerprint of magnesium, the fingerprint of radon. So here we see the fingerprints, and remember, different atoms have different fingerprints, just like you have different fingerprints from me. So we can see these fingerprints here on Earth, and then scientists using a telescope can look up at planets and stars and galaxies, and they can look at the light. They can look at the light entering our eyes, and they can see this absorption, these fingerprints, and they can compare it. Just like if you're at the scene of a crime, a police officer might find a fingerprint and compare it to yours. Scientists can compare the light to these fingerprints here. And what do we learn? Planets, stars, galaxies, they always find the same fingerprints of atoms that we have on Earth. That's very interesting. Whenever we look at something very far away, the light has the same fingerprints as the stuff around us, like your phone. Your phone is made of atoms. Those atoms have fingerprints of light. When we look up at a star, we might see the same fingerprints from the atoms that make up your phone, like carbon and silicon and hydrogen and calcium and carbon, hydrogen. It's the same material. So let's answer our question. What are stars made of? They're made of the same atoms here on Earth. Stars are not different material. It's the same stuff, the same atoms. Oh. Now, there are certain ingredients. Just like you have certain atoms like carbon and water, hydrogen and oxygen, stars have certain atoms. Here are the ingredients. Stars are made of 70% of an atom called hydrogen. Have you heard of hydrogen before? 27% of the atom helium. You ever breathe in a balloon and then your voice is all high because of helium? Oh, stars are made of 27% helium. And then a little bit of carbon. Have you heard of carbon? Nitrogen and oxygen. Nitrogen and oxygen, that's the same atoms that are in our air. And then 1% of other atoms. But it's the same material here on Earth. Okay, Mr. Thrasher, Mr. Thrasher has a diagram. I'm going to move my picture. Ooh, look at this. This is showing the same thing. So look at blue. A lot of hydrogen. We have a bit of helium, carbon, nitrogen, oxygen right here, and then green is some other types. But this is what's important. It's the same type of atoms. And now you've learned how scientists have found this. It's not just Mr. Thrasher's just telling you. Now you're learning, what did scientists do? Oh, they looked at the light. They noticed the fingerprints. And of course, we know that light enters our eyes. We know that certain atoms absorb and scatter, And based on what light gets absorbed, that's the fingerprint. And then you can determine what type of light that is. That's how scientists were able to learn this about stars. Now, you're going to do this. You're going to be an astronomer. You're going to be a scientist for our last activity. You're going to look at light that's getting absorbed, and you're going to use that to identify the atom. Now, to do that, Mr. Thrasher is going to help. To do that, we have to remember how to measure. You're going to have to measure wavelength, or at least read wavelength off of a graph. Don't worry, Mr. Thrasher will help. In our class, we usually use meters. Remember meters? Meters are a distance about this big. These wavelengths, though, are measured in something called nanometers. Nanometers. They're very, very small. Now, this isn't very important, except it's a different way to measure distance. Just like we have meters, we have feet, we have inches, we have centimeters, nanometers, very small, just another way to measure distance. But we're going to look at wavelength, and you're going to see the measurement will be nanometers, nm. But this is wavelength. That's wavelength. Okay, your last activity for the year. You're going to go on Canvas, and you're going to answer some questions where, look, you see two graphs. Ooh, this is a little scary, but don't worry. Remember how we said all stars have a graph like this, where it's showing how much light and the wavelength, the type? This is kind of a zoom in. This is kind of like the bottom part. See this? So the graph really kind of goes up and down, right? Up and down. We're just looking at a piece of the graph to make it a little easier. Again, this is how much light. So a lot of light, more, more. And this is, oh, look right there, wavelength. That's the type of light. Okay, and look, we see those same absorptions. Look right here, a lot of light. Ooh, absorption. This is for a certain atom at a certain wavelength. So down here is wavelength. Okay, right here, this represents 400 nanometers, but the wavelength right here is 400. What's the wavelength right here? That's 450. The wavelength right here is 500. Ooh, got to be a little careful. what do you think the wavelength right here is? What number do you think? Ooh, this is kind of halfway, right? 500, 550. This would be about 525. So this can be a little difficult. Right here's 550. Here's 600. What do you think, like right here is? What do you think right here is? What wavelength? Maybe 610, maybe 620, maybe 630. If you said something like that, good job. So you might have to practice reading in between. Okay, now here's what your activity is going to be. There are two stars. One of them, look right here, red. That's the sun. That's our sun outside. Look at these absorptions. You're going to look at three, like here's one. Maybe here's two, maybe here's three. Okay, you're going to look for these absorptions, these drops, and you're going to identify the wavelength. Oh, okay. And then once you know the wavelength, on Canvas, you're going to see this table. Let's pretend there's a big dip right here, okay? So the graph is going like da, 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 da. Big dip right here, right here. What wavelength would that be? Oh, that would be 400. So if there's a dip right here, fingerprints, we could use this table. If this is 400, we want to look for 400 wavelength. Let's see, 400, no, 400, ooh, close. No, let's see. Oh, look right here, 400. What atom is 400? What atom has a fingerprint at 400? That's calcium. Oh, so you're going to write a sentence. And don't worry, look, there's an example right here. You're going to look for a dip. Maybe, for example, you find an absorption right here. You would write down, ooh, one absorption is at 4 here. Let's do this. Mr. Thrasher is going to exit, and here, Mr. Thrasher is going to type. Okay, one absorption is at 400 nanometers. Okay, we're just kind of pretending. If it's 400 right here and 400, that's calcium. Okay, and that is the atom calcium. Done. You just answered one of the questions. So that was just practice. Okay, notice there is not really a dip right there. And then you're going to do this for the sun 2 more times. Look at all these dips. You're going to do 3 total. So maybe right here, okay, what wavelength do you think this dip is at? Maybe 430, maybe 440. You would go right here. What do you think it corresponds to? Now, it's okay, notice, look right here, hydrogen, hydrogen, hydrogen. Remember, if I go back, sometimes atoms have multiple, look at this, oh my gosh, there's many types of light, many wavelengths. In here, we see that there are multiple wavelengths. So it's okay if you have 2 dips, 2 different wavelengths, and they're both for hydrogen. That's possible. That's possible. Okay, but you want to find 3 different, maybe 1, 2, 3. Try and read that wavelength and then use this graph. This is difficult, but this is our last activity. Then you're done. And again, this is what real scientists are doing. Okay, you're doing real science to identify the atoms that are in stars. So this is in Canvas. Okay, this is your last activity. When you're done with this, that's the end of our semester. I certainly miss all of you. I wish I could see you in class and say goodbye. Of course, if you have questions, you can still email me, email Ms. Chavarin, and she can help you out. Okay, but this is Mr. Thrasher's last video. This right here is your last activity. And then the next 2 weeks, no new material from Mr. Thrasher. The next 2 weeks is just in case you need to make up work so you can earn credit. Some of you, You already have credit. You have 80% or 90%. Some of you have done a fantastic job. You have 2 weeks to relax. Take a break for 2 weeks. But some of you, if you have not been completing work, if it says no credit on Canvas, you need to keep working. All right, submit these assignments. Watch the video so you can earn credit. That's your job for these last 2 weeks. Okay? I wish all of you the best. Take care. Feel free to email me. I'll reply. But that's it. That's the end of my video. Thanks for watching and have a great summer break. Goodbye.